Okay, boys and girls, today we are identifying and explaining patterns on a multiplication table. Okay, you can use a multiplication table to explore number patterns. So this is a multiplication table, and the first thing they want you to do is write the products for the green squares. What do you notice about the products? So we are going to write the products for the green squares. We'll start over here on the row. Okay, row is only 8, right? Yes. And then if you go down, it's A and 0. If you look at the yellow, 8 and 0. So what is 8 times 0, guys?
8. 0.
0. Okay, so write that in on the first green square. Now let's go over here again. The next green square is on the 7, right?
Yes.
By the 7, but go up. Then it is on by the what?
1.
No. Go up. You go over on the 7. You go up on the 1. What is it? A 1. It's 7 times 1. What is 7 times 1?
7.
Okay. Then you go to the 6. It's 6, and then go up from the green, which is 2, which is 6 times 2 equals
12.
Okay, then go 5 over, and then it's 5 and 5 times 3 is 15. Okay, we're going to keep filling these out. Okay, boys and girls, what do you notice about the products? Wyatt, what did you just say?
It goes in a pattern all the way to the middle of the square.
It goes in a pattern, but what kind of pattern? What are you saying?
This acronym.
Okay, you can see that the products are the same, okay? But when you reach the middle, they change order, don't they? Okay, 0, 7, 12, 15, 16, then it changes 15, 12, 7, 0, doesn't it?
Yes.
Okay, so let's write that down. Okay, we see that there are some same products. So we wrote there are products that are the same, because there are same products on this line, on these lines. Also, we also said when we get to the middle, it changes order, or the order changes when we get to the middle. So after 16, instead of going with 0 again, it starts with 15 and it goes back down to 0, right? Okay. Okay, now we're going to write multiplication sentences for the products on our math board. What do you notice about the factors? Okay, so the multiplication product we have is 8 times 0, right? 8 times 0 equals 0. 7 times 1 equals 7. 6 times 2 equals 12. 5 times 3 equals 15. 4 times 4 equals 16. And then 3 times 5 equals 15. 2 times 6 equals 12. 1 times 7 equals 7. 0 times 8 equals 8. Yes, I meant 0 times 8 equals 0, not 0 times 8 equals 8. Okay, so what do we notice about the factors? They are the same. And you can erase the words. The same factors, but different order. Okay, the next problem. Will this be true in the yellow squares? Will it go in with different factors, getting the same answers but in different order, same factors but in different orders of the answers? Let's check it out. Let's do all the yellow factors. Okay, will this be true in the yellow squares? We said yes. And what property are we using?
The
are using the commutative property. And the commutative property says what?
You're just switching the numbers around.
You are switching the factors but still have the same answer. You can switch the factors. You can switch the factors but get the same answer. Okay, so instead of write the products with the yellow squares, which we have already done, now complete the columns for 1, 5, and 6. A column goes down, okay guys? So we are writing all the answers for 1, 5, and 6. Okay, so all the answers for 1. 1 and 0 is
0.
1 and 1 is
1.
1 and 2 is
2.
1 times 3 is
3.
okay, we're going to keep going. Okay, we finished all the 1 column. Now we need to finish all the 5 columns. 5 and 0 equals 0. 5 times 2 equals 10. 5 times 3 is already 15. I already have it. 5 times 4 is 20. 5 times 5 is 25. Keep going all the way down. Now we need to do 6's. 0 and 6 they already have. So 1 times 6 equals
6.
1 times 2 is already, or 6 times 2 is already there. 6 times 3 is
18.
18. 6 times 4 is
24.
24. 6 times 5 is
30.
30. 6 times 6 is
36.
36. 6 times 7 is
42.
42. 6 times 8 is
48.
48. 6 times 9,
54.
54. And 6 times 10,
62.
66. Okay, look. The product for 1 is 1. The product right here is 5. 1 and 5. And here is the product for 6 is 6. 1 plus 5 equals 6. This one, 2 plus 10 equals 12. 3 plus 15 equals 18. 4 plus 20 equals 24. So the pattern is the product for 1 and the product for 5 added together equals the product for 6. Let's write that down. Okay, so I cleaned off the rest of the numbers. So you have 1 times 2 equals 2. And then 2 times 5 equals 10. 2 plus 10 equals what? 6 plus 2 equals just 12. 3 times 1 is 3. 3 times 5 is 15. 3 plus 15 equals what is 18. Okay? So the product of 1 and 5 equals the product of 6. So if you added the answer to this and the answer here, you're going to get this answer. So let's put in here. 8 plus 40 equals 48. Okay, what property does this show? What property does this show? It shows the distributive property. Write that down. And it'll be on the board. Okay, boys and girls, we have shaded the rows for 0, 2, 4, 6, and 8, and 10 yellow, like it says right there. Now, it asks, what pattern do you notice about each shaded row? What do you notice about all these numbers?
Going by 0, 2, 4, 6, 8, and 10.
On all of them?
Yeah.
What about on the row for 4? Does it go 0, 2, 4, 6, 8, and 10? What about the row for 8? Does it do 0, 4, 2? That's not the pattern. Callie?
In the 2's row, It goes.
Okay, I'm asking for all the rows, not specific rows. What is a pattern, or what do you notice? Not a pattern. What do you notice about all those answers, all the products for all those?
Counting by that.
Well, yes, that's what multiplication is all about. You are skip counting by that number. That is not what I'm asking for.
It's counts by 10. It's skip counting.
I already know that. We are skip counting. That's what multiplication is. It will skip count by those numbers.
We're going by 2s.
No, we're not, because the 8 is not going by 2s. 8 is going by 8s. 10 is going by 10s. 6 is going by 6s. 4 is going by 4s. I'm asking, look at all these numbers. What do you know about them? 10 minutes.
That all of them are skip.
Quit looking at them like they're in rows. Look at them like they are just numbers. What do you notice about all of the yellow numbers? Jacob? Thank you. All of them are even. All of the products are even. Another pattern that you may have noticed is that they all end in either a 0, or a 2, or a 4, or a 6, or an 8. They can all end in those numbers. Okay, compare the rows for 2 and 4. Look at row 2 and row 4. Now you can look at the rows. Look at row 2, all the numbers in row 2, and look at all the numbers in row 4. What do you notice about the products? Okay, no, row 4 does not count by 2s. Row 4 counts by 4s. What do you notice when you are looking at the products for 2 and 4?
That in the 2s, it's like in
Okay, boys and girls, tell me, what do you notice about the products?
Double the number in the 2s row equals the number in the 4s.
Okay, you double the products for the 2s row to equal the products for the 4s row. Write that down. Okay, now we are going to shade the columns for 1, 3, 5, 7, and 9 blue. Let's do that now. Okay, I shaded the column for 1, 3, 5, 7, and 9 blue. What do you notice about the products for each shaded column? What do you notice about the products?
It goes even, odd, even, odd. The pattern goes
The products are repeating even, odd, even, odd.
the 2 teaspoons.
Okay, so the products are repeating even, odd, and the shade, and we already said that. Now, compare the products for the green squares. What do we notice? We said all the products are even in the green squares. And then we said about the factors, if we're looking at them, one of the factors is odd and one of the factors is even. So one factor is odd and one factor is even. And then what other pattern do we see? We see each row or column is counting up by the number on the outside. So the 1s column is counting by 1s. The 3s column is counting by 3s. The 2s row is counting by 2s. The 8th row is counting by 8s. That is our pattern.